For those that have just arrived, we're just going to wait another minute or two for the last few to arrive, and then we'll get started. Okay, well, good afternoon, everyone. My name is Craig Haney, and I am the Director of Marketing at Energent. First of all, I wanted to thank you for taking the time out of a very busy schedule. I know it's the afternoon before a long weekend, and I appreciate everyone's time significantly. So I hope that the next half hour or 45 minutes is real valuable to you as you learn a little bit more about monitoring and targeting principles specifically for the healthcare sector. Monitoring and targeting has evolved since its development in the 1980s. It was developed in Europe in response to calls for energy reduction strategies. Since then, the technology to monitor energy and set baselines and targets have improved, providing improved baselining, more reliable data, and better interfaces to view and interpret this data. Today, there are a number of ways to monitor energy use and compare this use to targets, hence monitoring and targeting. Today's webinar will outline the basic principles of M&T and how it can significantly reduce a hospital's energy consumption. There will also be one more theme during today's webinar. Monitoring and targeting is a participation sport. Energy managers and facility operators need to be engaged and active to act on the information that a monitoring and targeting system will provide. No action means no savings. If you have any questions during the presentation, please use the question tab to the right of your screen and type your question. We will save some time at the end of the presentation to answer as many of the questions as possible. The presentation will take about 30 minutes and we'll leave about 15 minutes for questions that people may have asked throughout the webinar. The webinar will also be recorded and posted on the Energent website. So if you want to refer to this webinar at a later time, you are able to, as well as you're able to forward the link to any colleagues that may have been interested in the topic but unable to attend. So let's begin. We will begin by explaining a little bit about what an energy model is. From there, we will lay out the 5 basic principles of monitoring and targeting. These principles are based on a recently released ISO 50001 guideline, so they're very well accepted across all sectors involved in energy management. We will spend some time going through the ISO 50001 guidelines and how they can be related to the hospital sector. We will then focus on the value of real-time data, and we'll try to debunk the myth that real-time means only sitting in front of a computer screen looking at graphs. We will then present 2 case studies in which Ontario hospitals realize significant value through the Energent platform, but in 2 completely different ways. Finally, we'll tie all of the components together in a neat little bow to ensure you have the takeaway messages you need to start realizing value immediately. As always, we'll leave some time for questions to ensure those that need clarification on anything that we spoke about today will have the answers they need. So let's move on to the first part of our webinar. What is an energy model? The basis of monitoring and targeting program is an accurate energy model. To ensure everyone's on the same page to begin, I want to explain briefly what an energy model is. An energy model is a mathematical equation that represents what an energy consumption should be. Based on a series of drivers, it predicts the electricity and natural gas consumption levels. It is represented by a graph that the actual consumption is compared to. To understand this, let's investigate the drivers a little bit further. These drivers are the causes of energy consumption. For example, weather is an obvious energy driver. When it's hot, there's cooling needed to keep the hospital at a certain temperature. This cooling uses electricity. In the winter, natural gas is used for heating. Well, the days of the week are also important. The hospital is not as busy on the weekend as it is during the week, as the administration staff is often not in on the weekend. Holidays may impact the energy consumption as well. Patient numbers are another driver, as well as the humidity outside. Since humidity is often an important component to a facility manager's operational plan, outside humidity plays an important role in the type of heating and cooling, or both, that are occurring at the hospital. This mathematical equation is driven from historical data. The farther we can go back, the more accurate the model will become. Most often, energy models are driven from 2 years' worth of historical data. Once all this information is collected, it is represented in a graph that looks similar to the ones on the next slides. So here we see a single line, and this is an electricity consumption line for an Ontario hospital. You can see the differences between the weekend and the weekdays. Do we know how well they're doing? Well, not really. By adding a model to the graph, the model will then provide context. So now we can see that the model, the blue line of the predicted consumption, is well above the actual consumption, which is the red line. So here we can see that this hospital is performing very well in accordance to what the predicted model is. So now we understand this basic concept of energy modeling, and hopefully that'll help you work through as we do the rest of the presentation. So now let's go on to M&T principles. There are 5 basic principles of monitoring and targeting that are necessary across all projects. By following these 5 principles, you will give your energy management program the best chance of success. Monitoring and targeting is more than a tool. It's a philosophy of committing to understanding how your facility uses energy and taking advantage of the data available to improve conservation techniques. So we need to measure. We need to measure and track your energy data to allow you to effectively manage it. We also need to make it part of the plan and incorporate energy management into the overall strategic plan of the hospital. We need to execute on that plan. We need to implement energy conservation measures because energy management is a participation sport. We need to check and monitor the progress of the projects, and we need to act on the opportunities that are presented to lower your energy consumption. So the first principle is you cannot manage what you don't measure. Every good monitoring and targeting approach begins by understanding this basic principle. You cannot manage what you don't measure. This is true for a number of other management situations as well, but is especially true for energy management. If you want to manage your electricity consumption, understanding how much you consume, when, and where are essential to a successful program. It starts with a baseline. We need to understand what your baseline energy consumption is before we can effectively manage that consumption. The baseline or model provides this context, as we just saw. We don't know how efficient you are operating until we understand the data that affects energy consumption. Weather, holiday, humidity, and patient numbers are often important drivers for hospitals to understand this energy consumption. Another aspect of measurement is consistency. The more data that is incorporated into a monitoring and targeting system, the more accurate it becomes. And as with any modeling exercise, a larger sample size increases the ability to predict patterns. Measuring energy is relatively easy as there are many well-defined metrics to use as part of a monitoring and targeting program. There are 2 aspects of measurement, though, that are critical to maximize the energy management opportunity. Those are accessing the measured data in a timely manner and choosing the most appropriate metrics to measure against. The first point, accessing the data in a timely manner, allows facility operators to take advantage of the information they are collecting. If there is an overconsumption issue of significance, utility bills only provide a glimpse into the past. Most of the time, this information is 6 to 8 weeks old, and reviewing the situation that happened 2 months ago makes it very difficult to decipher exactly what happened. The second aspect is for you to ensure you understand what metrics are important for your hospital and implement the program to measure consumption against those specific metrics. For example, if energy intensity is important, then ensure you have all the information necessary to understand how many kilowatt hours and meters cubed are consumed and the total square footage. If the hospital's carbon footprint is important, then understand how the carbon footprint is measured and ensure that the tools are in place to measure this metric. The next 4 principles that we'll go through are part of the ISO 50001 Continuous Optimization Program, which utilizes monitoring and targeting principles throughout the standard. Let's take a look at each one of these in a little bit more depth. To be successful, energy management must be incorporated into the strategic operating plan of the hospital. Hospital energy costs are typically between 2 and 3% of the overall operating budget, and this number is expected to increase by almost 50% in the next 5 years. If hospital isn't including energy management into their strategic plan, then it is imperative that the facility team build the case to include energy as part of the conversation. Energy is now a manageable expense, and facility operators have an opportunity to educate others on how this can be done and the value of that management. Including it in the plan also helps hospital leadership understand the importance of metrics. To ensure that the energy management is in front and center of the strategic plan of the hospital, facility operators can work to find metrics that showcase the value that a well-run hospital is to a variety of stakeholders. These metrics can include dollar savings, carbon footprint, and project analytics. It is imperative that hospital leadership share their expectations with the operations team to achieve the goals of both parties. Take ownership of energy and share its importance with leadership to ensure that energy management becomes an important strategic asset for the entire hospital. But planning only gets you so far. Execution is where energy conservation measures will yield the impending results. As I mentioned earlier in the presentation, energy management is not for armchair quarterbacks. It's for facility managers that are interested in turning this data into action to ultimately conserve energy. Monitoring and targeting will help you implement the most effective energy conservation measures by providing an objective way to prioritize projects based on cost and projected outcomes. Every facility manager has a long list of projects that they want and need to implement. Prioritizing these projects based on building a business case will help achieve buy-in from all levels of the organization for projects that are important to energy conservation. By creating scenarios, energy monitoring and targeting system will be able to create a what-if business case for conservation measures. If we do X, what are the projected savings? The operators are then able to present a plan that is objective and consistent with the operating plan of the hospital. Throughout the project, measuring the success of the project is based on the expectations, builds validity into the model, and opportunities for further projects and success stories. By implementing the projects that have the highest return on investment and chance for success, these lead to lower energy costs and ultimately greater conservation achievements. Moving forward, the fourth principle of monitoring targeting is to check and monitor progress. This principle is designed to ensure you are constantly measuring your progress on key metrics and KPIs. During the planning phase, key metrics were chosen based on strategic goals of the hospitals. These metrics were taken into account with the energy conservation measures were chosen, and now we must check to ensure the conservation measures are achieving the desired result. This does not have to wait to the end of the project. Milestones should be built into the project plan to monitor the progress of the projects. Real-time analytics provide relevant data during this phase, providing important insight into the progress of the project. It is also important to have done the what-if scenarios that we talked about during the implementation phase so that these expectations can be clearly set. If there is no understanding of the timeline for a return on investment for a capital improvement, then it is difficult to check and monitor the progress of the project. For operational changes, work with key staff in your hospital to understand what the feedback has been when we're looking at running a project that will affect energy use. Will the staff respond? Have surveys been done to see? Does project have buy-in from all levels of the administration? All of these are important to improve the quality of metrics chosen throughout any project. This will actually be the topic of May's webinar. It will be focused on green teams, what's worked, and why it has worked. Look for that for coming up at the end of May. So the final and fifth principle for monitoring and targeting is acting on the opportunities. So continuous improvement means plan, do, check, act, and repeat. The final principle in energy monitoring and targeting is to take the necessary actions to continuously improve on past performance. We like to call this creating a culture of conservation. By comparing energy data to important metrics, we create the opportunity to continuously improve over time. If these opportunities are not acted upon, then there is no chance that savings in conservation will occur. We want to create a repeatable process to drive conservation initiatives moving forward for years to come. One of the challenges of energy conservation measures is their one-and-done nature. Without the ability to compare historical values, The gains found by completing an energy conservation measures are at risk of being lost over time. M&T systems track historical data and make it available in reports to see how hospitals have done over that time. When the information is normalized against the model, relevant comparisons can be made over previous years, ensuring savings are continually realized. These can include operational changes or ensuring capital retrofits maintain their expected conservation targets. Finally, the what-if scenarios can identify which opportunities to address first and will yield the best returns. If these little projects over time can yield very strong conservation returns, then these little projects we call the golden crumbs of energy management. So we've now reviewed the 5 principles of monitoring and targeting. The second part of the webinar will focus on the value of getting this information in real time, having this information available when you need it from one central location. Based on the 5 principles of monitoring and targeting, we want to now talk about the quality and timing of the data received. So, one of the benefits of all this connectivity is access to the tremendous amounts of data. One of the challenges of all this connectivity is the tremendous amounts of data that we have access to. What are we supposed to do with all this data? It isn't useful if it doesn't have context. And what are we supposed to do with all this data? We have to have context with this data, and we need to present it in meaningful ways. Specifically, how are we going to help turn this mountain of data into useful information and then ultimately knowledge? An energy management information system enables access to real-time data and gives facility managers the information they need to act in a timely manner. So let's investigate real-time data and how operators can use this information to lower consumption and ultimately reduce the hospital's carbon footprint. So there are 4 primary advantages of real-time data. They are data granularity. It provides an opportunity for alerts and notifications. We can analyze the success of specific energy conservation measures, and we have the ability to affect behavior. So let's start with improved data granularity and the access to accurate data. Data granularity is about access to information that is relevant and timely. There are 2 aspects of data granularity that we want to investigate. First, it's the timely manner of that information, and second, it's the quality of information that allows facility operators to act. By comparing real-time energy consumption to the energy model, facility operators can see when energy consumption is over, on, or under predicted levels. By understanding the components of the model and its current operations of the hospital, assumptions can be made as to the reasons for any changes to the consumption levels. The quality of data is enhanced when there is more knowledge of where the consumption is coming from. One of the most common ways to do this is to add energy meters or submeters within the hospital. This can help separate the consumption from one area of the hospital to the other. This gives significantly more information as to why consumption changes and the opportunity to reduce that consumption. For large hospitals with sprawling campuses, this is an investment that must be looked at to improve the quality of the data available. For some events, alerts are the first defense against costly equipment failure. Equipment failure doesn't always mean catastrophic events, but it could mean simple thing like a broken valve, but may cost the hospital hundreds of dollars a day. Our first case study will highlight that situation. These alerts and notifications are generated when there is a statistically significant event that causes an increase or decrease in energy consumption that's caught by the system. These alerts are typically received by email by the facility operator and gives them enough information to begin investigating the possible causes of alerts. The alerts are based on comparing this actual energy consumption to the predicted energy model. When that consumption changes, alerts can be generated to inform the facility operator that there is something abnormal occurring. This is one of the most valuable energy-saving tools that real-time data provides. By acting on these waste events quickly, facility managers can significantly improve the overall operating efficiency of the hospital, saving thousands of dollars. The tracker system is a tool that Energent provides by enabling facility operators to track specific costs, actions, and results of these waste events. By implementing a tracker system, information can be shared across the organization and quantify projects, savings, and return of investment for energy conservation measures. By using alerts and notifications, hospitals can now track specific costs and savings for all the projects. Quantifying savings is an essential to any energy management plan. Whether you're conducting a turn-down Friday operational change or investigating retrofits, understanding the specific savings that are generated from projects or energy conservation measures provide valuable feedback to all levels of the organization. It is not only important for facility managers, hospitals leadership and administration is very interested in measuring the cost and saving of certain events, and the building a business case based on reasonable and defensible assumptions. It also helps to understand which projects are more successful in providing cost savings and which projects do not have the same level of success. This information is vital for the 5 principles of monitoring and targeting to ensure projects achieve the savings that were expected. Finally, we want to utilize this real-time data to engage more staff to participate in energy conservation. Modifying behavior is the driver for operational changes within any hospital. When the staff are aware of the impact that their actions have on the hospital, it can be a powerful motivator and have a significant impact on the operational efficiency of your hospital. One of the most powerful ways of modifying staff behavior for energy conservation is to utilize challenges. In most cases, groups respond well to challenges and games, and when well planned and executed, yield great results. It is vital to engage stakeholders at all levels in the planning and execution of these challenges. Hospital leadership and team leaders have a vital role to play in staff engagement for the energy management. But facility operators should also play a key role as the independent measurement tool and also as a subject matter expert. Provide suggestions and estimated impacts, as well as information on how energy is used in the hospital. The more people understand why it is important, the more engaged they will become. Finally, showcasing the results as soon as possible. Providing that feedback is vital to the success of any challenge. Real-time information provides that immediate feedback opportunity. So now let's look at monitoring and targeting in action with the following 2 case studies. So these 2 case studies are for hospitals that are in the Ontario area. So scenario 1. Our first case study focuses on a unique scenario. The hospital client uses cooling towers to manage their cooling needs, very similar to the one pictured here. Energen software platform and their energy analysts were able to detect a situation which a cooling tower wasn't operating at a maximum efficiency and were able to measure the exact impact of that situation. Cooling towers basically work by pumping warm water to the top of the tower and spraying a fine mist, releasing the heat up and out of the cooling tower and dripping cooled water down below ready to be recirculated. For the pump to work efficiently, there needs to be a constant level of water in the bottom of the cooling tower. In most cooling towers, there's an automatic fill valve that moderates that water level to ensure the circulation system works in an efficient manner. If the water is too low, the pump has to work much harder to maintain that constant level of water throughout the system. When an electric pump has to work harder, it takes more electricity to run that pump, therefore more money. In the situation, the fill valve at the client site was broken. Monday to Friday, a facility operator manually filled the cooling tower to ensure levels stayed at the optimum size. Well, what happened on weekends and during holidays when the operator isn't on site? Well, let's see if we can find out. This is a QSUM chart. In energy management, it is a very important summary of the net benefits of energy conservation measures. A QSUM chart is the cumulative sum of difference between the predicted consumption or the model and the measured consumption or the actual. A slope that is down and to the right shows a savings trend. A steeper slope indicates more savings, and a flat line indicates that actual consumption is equal to the predicted consumption. This is actual client data from our hospital and what the energy analyst and operator would see. Typically, this hospital saw a very nice savings trend, a smooth downward QSUM. But notice at the beginning of July and periodically throughout the month, there would be these blips on the slope that are circled in red. Between these times, the slope continued to be very strong. But what happened? What was the cost of each of these plateaus? Well, let's look at some of the specifics. The steps in the QSUM were caused during times when the operator was not at the hospital. Because the fill valve was broken, the operator would manually fill the cooling tower to the optimum level, ensuring the pump worked effectively. When the operator was not there, the cooling tower water level would drop below the optimum level, and the pump would have to work much harder to circulate the water through the cooling system. This caused an increase in electricity being used by the pump. After identifying the problem, it was a quick solution to replace the fill valve. The valve was a little expensive, about $2,000, but they were able to make the business case very quickly that replacing that fill valve made a lot of sense. Here's the bottom line. The extra electricity was costing the hospital approximately $600 a day that the operator was not on site. Extrapolating that out and assuming that the operator works about 260 days a year and half of those the hospital is cooling, that's 55 days at $575 per day that the cooling tower would be over-consuming electricity. That means that it would have cost the hospital over $30,000 a year in extra electricity costs. Without the granularity of real-time data, this problem would not have been identified. The daily consumption information was necessary to see the change in consumption day by day. The other part of the system that was critical to the identification of the problem was the accuracy of the model. Because the Energent modeling engine is robust and able to incorporate a number of different inputs, the accuracy and reliability gives confidence to the operators and energy analysts who are reviewing this information on a regular basis. The next scenario is very different in the way they use the Energent platform. It will demonstrate how Energent provides visibility and accountability like never before. So, recently, in the summer of 2011, about a year ago, 10 Ontario hospitals experienced a C. difficile outbreak. This presents a particular challenge to building operators for a number of reasons. First, the cleaning solution they use has a very heavy odor associated with it. Because of this, operators are often required to run continuous fresh air through the facility 24 hours a day. Depending on the time of year, this will affect either your electricity or your gas consumption. Once again, let's look at a case study to see how this information was used by the hospital. So this particular hospital experienced the C. difficile outbreak in November of 2010. As a result, the operators were required to run continuous fresh air at the hospital from November to February. Because the air was being drawn from the outside, was cold, it required the heating system to heat all the fresh air much more instead of using a portion of recirculated air. This client was very interested in understanding the specific costs associated with this event. So let's take a look how it was presented on the Energent dashboard. As you can see, this hospital at the beginning had a slight decrease in Q-sum from the beginning of November to November 24th. On the 24th, they switched to 100% fresh air, which required extra heating. This continued until February 17th. As you can see, by mid-February, the Q-sum restarted on the downward savings trend, as was going on prior to the outbreak. Now, this chart, you can see a little bit more detail. Through October and November, there was consistent savings trend with natural gas. And as you can see on November 24th, there is an inflection point that indicates this change in operations. This caused a significant overconsumption event until the outbreak finished and normal operating procedures were put back into effect, bringing the Q-sum back down to towards a downward savings trend. Well, how do we use this information other than, well, of course we spent more money, we're heating more air. Well, what do we quantify the cost? This chart quantifies the cost of the extra natural gas used during the outbreak. Although the numbers may be a little bit difficult to see, there's an area circled in red that is the cumulative cost of the outbreak. The column to the left is the weekly cost. As you can see, the total cost of the extra natural gas used because of the outbreak is just over $35,000. We can clearly associate these specific costs to the outbreak as the operation of the hospital changed at the same time as the consumption changed. This gives the hospitals the opportunity to now include energy as part of a cost of an outbreak. So whether they are reporting to their board or to the government, this is extra visibility into how energy is being used, which was not available in such a clear and concise manner prior to real-time energy management systems. The hospital included the extra natural gas cost in the report to ensure all costs were captured. Now, I wonder if the 10 hospitals that had the outbreak last summer happened to include extra electricity in their reports. So to summarize today's webinar, we went over the basic concepts of an energy model, We covered the 5 monitoring and targeting principles to measure, manage, plan, do, check, and act. By following these 5 principles, your energy management plan will have the greatest chance of success. Real-time monitoring and targeting is an essential tool to ensure the program and energy conservation measures are achieving the targets that are set for them. When it comes to accessing the data, we feel that real-time data gives facility operators the data in such a way to turn it into knowledge that will enable improved decision-making. The data must be at a level that is relevant for operators, and alerts and notifications must be accurate and timely so that there's an incentive for operators to act on them. The information must be easy to find and accessible when you want it, and we must be able to find the data needed to measure specific successes from projects, both capital and operational. Finally, we reviewed 2 case studies that focused on 2 unique ways to use real-time monitoring and targeting in regular hospital operations. Well, Energent's been a trusted partner in the healthcare sector for many years, providing knowledgeable energy advice and analytics. We have customers across the country who use Energent to lower cost and improve efficiency. Energent is the first choice when it comes to healthcare energy management information systems. So we have 2 more webinars planned specifically for the hospital sector. On Wednesday, April 25th at 2 p.m., Energent will host a webinar about benchmarking in the hospital sector and how facility managers can use this tool to reduce energy consumption and ensure they are operating within expected boundaries. On Thursday, May 31st, Energent will host another webinar to discuss how to incorporate green teams into hospitals and how facility operators can be an important part of their success. So wanted to thank you for taking the time once again, a weekend before the day before a long weekend. For more information, please visit our website that's on your screen. We have a specific page dedicated to the hospital sector and your specific needs. You can find out a lot of information about Energent can help you manage these increasing electricity costs and better manage and understand the overall cost of energy. So we've got a number of questions here, so we're going to take some time now to answer these questions that we received during the presentation. So great question here. So usually a hospital is a very dynamic place with a lot of energy changes that are happening every hour depending on the growth, occupancy, and other things. Energy in hospitals are like stocks that change every minute. What is the practical limit to make helpful to monitor energy? Is it based on 1 meter serving all the sites or smaller meter serving critical locations or smaller buildings? So that's a great question. So the normal implementation strategy that we've done, that we've found the most success, is to start at the site level. So start at the envelope level of the hospital. And then once the information and the operations of the hospital are better understood, then strategically address sub-metering or adding more energy meters. This way, we're not going in blindly and just spending a significant amount of money just sub-metering. We want to have the analytics behind to understand where the best use is. So maybe it is a small building, maybe it is strategic areas of the one big building, bigger wings that you might want to sub-meter. But best case we know is that we can take the years of information we have from the site level and then support you on decisions of where to sub-meter. So that's typically the way we approach sub-metering. We start at the base level and then move into smaller and smaller areas depending on the value for the specific hospital. So another question here about ISO 50001. Is it specifically for hospitals? The answer is no, it's not specifically for hospitals. It's an ISO standard that is not specific for any industry, but it's very specific for energy management. We're going to do a webinar in that very shortly, so there'll be lots more information about that and how to utilize that new standard for your hospital. So from specific case study number 2, can you estimate the cost for the conservation for the CFM if 100% of fresh air is compared to the old model return air system? So what we'd have to do is take a look at some of your historical data and then compare that to the fresh air return and see where those differences are. That's where the energy analysts are best prepared to work with our hospital clients, because they're the energy experts. They're the ones that have seen this for dozens of hospitals across the country, as well as other industries from heavy industrial to commercial. So they're able to take advantage of their knowledge and share that with all of our clients. So we would work with our clients, and our energy analysts do, to make sure that the comparisons that we're doing for all your reports and all your information are very relevant. So back to the discussion of metrics, making sure that the metrics are relevant for you. How can we use real-time monitoring to increase employee awareness for energy savings? Well, that's great. For us, the experience that we've seen is that feedback is the most important. So when they do a project, so if they're turning down the lights, if they're turning down the air conditioning, or if there's a big construction project and there's a big retrofit going on, we need to be able to showcase those savings immediately so that we can showcase what happened. It's like when you praise your child or discipline them, you want to make sure that you do it right away so that message gets across. In the same way with these projects, we want to showcase the success right away, and then people can remember what they did and they can tie that into future projects, and that gets them excited. We could also make sure that we log all that data specifically so that the next project we do is even more successful, so we get learnings from there. So how successful have you been modeling electricity usage in a hospital? So it depends how you define success, but what we do, the way we model electricity, we compare that using the ASHRAE model and an R-squared value. So all of our models are IP-MPV compliant, so they do have the specific R value that are necessary for that compliance. But the other part of the modeling, which we're very passionate about, is to ensure that the client is participating in the modeling effort. The more we understand what happens at the client site, the better we can understand the drivers, and the more information we can get from the client will end up driving better modeling. So, to answer our question, we're very successful because all of our models are IP-MPV compliant, and we work very closely with our clients to ensure that we understand their hospital, their business, their operations, to make sure that we provide the best model possible. And that's a bit of a living organism. So we don't provide that to just a black box and there's your model. It lives with us, and we continually work with that. And finally, should monitoring be in the action plan for the 39711, and how about the cost to implement? Well, the advantage of monitoring as part of the 39711 compliance is that all of the data that you need for that reporting is available to you immediately. So there's no extra work that needs to be done to be part of that reporting. So certainly we think that there's a lot of value in that, and including that into your strategy for that reporting for next year, we think is very important. It's not a necessity, but it just requires a significant amount more work to go back to historical numbers to be able to gather that information. The cost to implement really depends on the number of models and the number of meters within your facility, and we're certainly willing to work with you to talk about what that cost would be to make sure that it makes sense across your organization. So community hospital is different from a small hospital in energy consumption levels. Can you provide us with levels from your case studies in the hospitals? Actually, yes. So that benchmarking study that we're going to showcase in our next webinar will be very specific, show you different hospitals at different sizes, so large hospitals, medium hospitals, and small community hospitals. So I mean, for sure that large hospitals have larger opportunities for savings, because a small percentage means a bigger savings from an actual dollar standpoint, but that doesn't preclude small community hospitals from saving significant percentages of energy and electricity. The nice thing about smaller hospitals is the ability to engage the staff. Often they're more of a community feel, and you can get the staff involved at a much better level, and often these operational changes, these low-cost or no-cost changes to doing these special projects, often in our experience have a better impact in the smaller hospitals. So it might be more cost effective for some of the projects to be done in the community hospitals. So yeah, so so small hospitals do have the opportunity to do savings, and you just have to maybe look at more operational changes from a cost benefit standpoint. Is there any more questions that we have? But timing is perfect. We're just over 40 minutes. So I wanted to thank everyone for your time again. This will be posted later on today on the Energent website, so if you want to forward that link off to anyone else that you certainly be willing to or able to in the next little while. And we look forward to you attending the next webinar on April 25th on the benchmarking study. So thank you very much.